Hello, everyone. Welcome back to Quantitative Reasoning Mathematical Modeling M155. In the previous video, we looked at misleading graphs and media claims. The main idea was that even accurate numbers can represent a misleading impression depending upon the scale, time period, or the way the information is displayed. Today, we're going to look at correlation, causality, and confounding. So we're going to refer to these definitions throughout, but you can make sure that you go and look over them at the end of the video. All right, so in example number one, a study examines the relationship between weekly work hours and GPA. Which variable is being used to help explain or predict the other? Okay, identify the explanatory and respond, and response variables. Okay, so what that would be weekly work hours is basically equal to explanatory variable, right? Your weekly work hours will be equal to your explanatory variable. The outcome that we're interested in is the GPA is equaling response time, or the response variable. So we can think of the relationship essentially as work hours and GPA, or work hours. There's a correlation between work hours and your GPA. But this does not automatically mean that work hours cause changes in GPA, right? Because many of you probably work a job or could work a job and you still maintain a really high GPA, right? It simply identifies which variable is being used as the predictor of, um, or the predictor, and which is the outcome, right? So a study relates weekly work hours to GPA. So, the explanatory, or the explanatory variable would be the weekly work hours, and then the response would be the GPA. So this would show me the GPA, but there's necessarily not that doesn't necessarily always mean that there will be a correlation between the two. Or if you work more hours, that your GPA is going to be lower than it would be if you weren't working. Okay. Example number two, describe the association. Suppose a scatter plot shows a moderate negative relationship between commute time and sleep. Negative means the variables tend to move in opposite directions. So, if, for example, commute time is up, then sleep tends to down, right? Versus, or I should say, and, if commute time is down, then sleep tends up. Okay. But the relationship is described as moderate, right? A scatter plot shows a moderate negative relationship between commute time and sleep. Describe direction and strength. Okay. But the relationship again is described as moderately negative, right? So the pattern exists, but it's not necessarily strong. If you commute, then your sleep tends to be lower, and if your commute time is down, then your sleep tends to be higher. But there's a moderately negative relationship between the two. Okay, so we would say that if there's a negative, we would say essentially that there is a negative or moderately negative association between commute time and sleep. Just a moderately negative relationship between it. Not that it's not that, oh man, if you do drive more, you're going to lose sleep, right? All right, here's the pause and try problem. This is identifying confounding, right? Suppose students who attend tutoring also spend more time studying. Researchers notice that tutoring students basically tend to have higher GPAs. When you go to tutoring, you tend to have a higher GPA than not going to tutoring, right? Researchers have found that, have noticed that that is true. That can we immediately conclude that? Can we immediately conclude that if tutoring, then oops, then higher GPA, right? Uh, okay, the logical symbol would be this tutoring. Okay, if tutoring, then higher GPA. That's a logical conditional statement, right? Can we conclude that? Not necessarily. We can't, right? Because study time could also affect your GPA, right? If you study, right? If you study more, then your GPA may go up, right? Because studying, the more time you study, the more likely your GPA will go up. And tutoring students may also study more, right? So we have, essentially, tutoring. If you go to tutoring, then you have a higher GPA, but it also could be true that if you study, then you can also have a higher GPA. Okay. All right. Example number 3. Evaluate temporal order. All right. Suppose researchers measure, you know, social media use and anxiety at the same time. Explain why cause direction is uncertainty. Okay. So if they do this at the same time and they find a relationship between them, can we say that social media use causes anxiety in us? I mean, what do you think, right? Think about that. I say no. And the reason is, you would say, well, why? Well, because we don't know which came first. Maybe you had anxiety before you picked up your phone and was scrolling on social media. Maybe you had a small touch of anxiety before that happened, and then it just amplified, right? So it could be social media use being up, then your anxiety is also up, right? But, or I should say, or it could also be, your anxiety or the anxiety that we have is up. And, then, social media use is also up. So if two variables are measured at the same time, the direction of cause and effect really may be uncertain, right? Because a study measuring social media use and anxiety at the same time, explain why causal direction is uncertain. Well, social media use is up, then your anxiety is up, but maybe your anxiety is up, and then the social media use was up after the fact, right? So there's no way, there's a little bit of uncertainty there. Maybe you didn't know you had anxiety. Maybe we didn't know we had anxiety before we actually started experiencing anxiety, before we started interacting with social media. Okay, so very important to consider. Example number 3, or excuse me, example number 4, compare causal evidence. Now we're going to compare two studies. Compare an observational correlation with a randomized experiment that changes the explanatory. So we have two that were considering. Okay, so we have, we'll label them study A and study B. Okay, so study A, let's say researchers simply observe two variables and find a correlation, right? That's what observational correlation is. Study two variables and find a correlation. Then study B with a randomized experiment. Well, a randomized experiment is researchers conduct a random experiment and deliberately change the explanatory value. So, random experiment in, and so they deliberately change the explanatory variable, which gives the stronger evidence of causation. I would argue with study B because random assignment gives researchers more control over other factors. So observational correlation, that is mostly association. While a randomized experiment, you get stronger evidence for causation. Okay. But that does not mean that every experiment automatically proves causation, but the design can give us a more stronger evidence. Okay. Okay. Common mistake. Suppose a student, so a strong correlation is not automatic proof. That's the big idea, right? Suppose a student R says R near one proves causation. So basically, if it's near one, they're saying that R is approximately one, right? Therefore, one variable definitely causes the other. Well, that's incorrect, right? So a correlation that's close to one, right, means that there is a very strong positive linear relationship. But a strong correlation is not equivalent to the proof of causation. We still need to examine it. So we got to study design and variables, the order, and all those sorts of things. Okay. So this does not necessarily prove causation. You can have a number that's close to this, but a strong correlation is not proof, right? It's not an automatic proof of a correlation, right? In closing, remember positive correlation of two things. So we have, let's just say, we'll say positive correlation. Let's say X is up, and then, you know, Y tends to be up, right? A negative correlation, that means, X tends to be up, then Y tends to be down. Okay. So that's what a negative correlation is. But again, correlation is not equivalent to causation. So whenever two variables are related, you got to ask another variable if another variable can be affecting both. So in the next video, we'll calculate and compare mean, median, mode, and the weighted mean. And again, thank you for watching.